All right, so my name is Matthias. I also work at JetBrains, but what I'm going to talk about here is NUKE, which is a pet project of mine that I maintain just beside work. Also, hi to Marat. I've seen you in the chat. Yesterday, I was actually fixing a bug that Marat was reporting, and yeah, nice to see you also, but also everyone else. So I will talk about. Let me also just make it full screen. I will talk about NUKE, which is a tool for doing build automation, and I also make the bold claim that it is actually modern build automation for .NET and C#. And I will start by giving you a bit of background about what I have seen so far in relation to build automation tools. So the first that I started, and everyone is using to some extent, was MS Build. And if you're doing something more complex with build automation, so just because of the time is a bit short, just quickly, build automation are all the things to actually build our application that involves things like compiling solution, packaging to NuGet packages, pushing them. But as easy as those few examples seem, if you put more effort or over time, those things become much more complex. And with MS Build, that's also possible. We can write we can write our own targets. We can also escape to something called task assemblies to write actual C# code. But all in all, MS Build isn't really handy for doing build automation. So after that, and that was still at the previous company that I worked at, after MS Build, we switched to PowerShell. We also considered something like PSAKE, but for the sake of simplicity, I think at that time we stick with PowerShell. For probably one of the reasons was also that PowerShell is also known from the DevOps, or at that time, DevOps was not a term yet, but it is known also for operations teams. Yet with PowerShell, it turns out that there are a lot of unknown unknowns. So just a quick example or two quick examples. PowerShell has a very, I would say, surprising way of comparing with null, for instance. Null must always be on the left side of the comparison. Also, PowerShell, for instance, does crazy things like unwrapping collections if there's only one item. So you need to force it to keep it a collection. So all those kind of stuff. At my previous team, we actually skipped fake, although at that time it was becoming really popular. Probably the biggest reason for skipping it was that we would have to learn F#. So fake is based on F#. We would need to put that requirement onto our complete team. We could also pick just one person maybe, but then we end up in a situation where this one person is not reachable, is on vacation or something, and our build pipeline is just standing still. So we skipped fake. After a while, and I was already working at JetBrains, and at that time I had another pet project, which was called TestFX. And I was still trying to figure out a good way of doing build automation. And I used Cake at that time. So Cake is based on C#. But the issue I had with Cake is that it is actually still a scripting approach. So what's missing with Cake is all the IDE tooling, including, well, Cake, they have actually extensions for many of the IDEs. Not all, actually, but Visual Studio and VS Code, at least. So I use Writer. That was missing. But still, with those extensions, it's still impossible to do some kind of refactorings, for instance, or to use find usages. So everything that we know how it works in normal C# code. And that was the time when I started doing my own thing with NUKE. Now, another disclaimer, and you might wonder, why should I use a build system if I have a build server like TeamCity, Azure Pipelines, and all that stuff? So yes, build server have the advantage. We can do continuous integration in a team. Yes, we also have historical monitoring, for instance, to see which tests are flaky and all that stuff. We have build parallelization, of course, to run tests in parallel, for instance. And we also have queue optimization. I'm not sure. I at least know that TeamCity is providing that, that when a certain build hasn't changed, then TeamCity will just use the previous result from it. Because if nothing has changed, then we don't need to build it again. And there are also some other optimizations in place. Now, on the other hand, some things that are not possible with build servers is with build systems, we can actually do local execution of our build. So that, with that in mind, we have a very fast feedback cycle. So if something is broken with our project, then just committing several times to the CI server isn't going to help us very much, because it might be blocked, or we block it for other folks. So the feedback cycle with build systems and local execution is really fast. Also, with build systems, we can properly debug our build. And we also have the advantage that we don't experience this kind of lock-in. So for instance, if we set up our build and it gets extended over time, then those build configurations, if they were on the build server side, we can't just say, okay, I want to switch to another vendor and use, let's say, Bitrise or GitHub Actions or anything, because that would mean we need to re-implement the whole build pipeline again in this other language. Let's say for GitHub Actions, it would be YAML. Everyone loves YAML, I know. All right. And with that being said, I will switch to a lot of live coding, actually. And I will start. I also have let me just switch here. I also have some kind of lineup here. So first, I will look with you at the setup and a simple hello world example. So in this case, we just have a solution. We have just a single project, but that all doesn't matter so much. What we do first, if we have our solution, is to install a global tool called NUKE. That command is also put on the documentation side. I have it installed already. And what happens if I call NUKE in this solution that's currently not built with NUKE, that we're going to get asked if we want to set up a build with NUKE. So I would just say yes. And now we're getting asked a couple of questions. For now, we'll just keep the defaults. So we're getting asked what our build project should be called. We'll go with _build, where it should be located in a subdirectory called build. We can also choose from a couple of versions. So you can see we also have the latest release. If there was a pre-release, you could also pick the pre-release and all those kinds of things. And also we are getting asked which solution should be our default. So many folks probably only have one solution. If you have more than one, then you can just pick none. But I will go with the default solution. And then there's also some more elaborate wizard that you can go through, which I haven't been working on for a long time. But at this time, we will just stop the wizard and finish the setup. Now, if I unfocus my terminal, then we can see Writer automatically reloads this solution, and we have a build project here. This build project, I get this question all the time. Why is it marked as being not built? That is because if with that build, you're building the solution and the build is currently running, then we have we're locking the build execution. So it would build itself, basically. So that's just to stop this building chain. And if we look into that solution, we can see we have a couple of bootstrapping scripts, which were cross-platform, basically. Those bootstrapping scripts do mostly the same, or they actually do the same, which is just to ensure that, for instance, in this case, I was picking the .NET Core as a platform for the build, but we can also use .NET Framework. That also works. But for .NET Core, for instance, what this ensures is that we have the correct version of .NET Core installed, which also takes into account the global.json file, just so that that's there at any time if we execute our build. We can also see here we have a marker file. This marker file, I'm not sure if that will change at some point, but this marker file is just to, it makes it a little bit easier for everything that's built around Nuke. It basically sits next to the .git folder. So if we just watch the file system view, here's the Git folder, here's also the .nuke file, and it basically marks the root directory of our complete repository. Why not using the .git folder? Because Nuke should work VCS agnostic as well. Okay, I will switch back. And now let's look at the build.cs file. And what we can see here is more or less the default implementation of a build. It's just some kind of scaffolding, basically. You can see our build class is inheriting from the Nuke build base class. And it defines actually a static in main method. So what does it mean? This is a simple console application. And everything we do here is just to delegate to Nuke as a framework to say, please execute the build. That's the same as here. And we can also define the default targets. We don't need to define default targets. We can also define multiple of them. That's also possible. But that's it for these for the entry point of Nuke. Now, what comes next, and I will just remove a couple of unnecessary things, is a couple of target definitions. So in build automation, we have this idea of build steps. In Nuke, they're called build targets, same as with MS Build. I'm not sure about Cake, but we stick with the name target. And usually, if I would do this live, what I like to ask people is to take a guess in what those clean, restore, and compile targets actually are in terms of C# language constructs. And I will give you a second to think about it, and we'll also explain it just now. So those targets right here, those are actual properties, which also leads to the fact that we have defined compile here as a default target. We could go here and just say compile, please rename it. And we have it updated here as well. The same goes for restore. Compile depends on restore. We can rename it here. So we have basically the exact same tooling that we know from any other C# project in the world, just out of the box, without any extensions that we need to install. That also leads to the fact that if I put a breakpoint right here and I start my console application, then I can just debug it. And after a moment and giving the debugger a bit of time to attach, then we can see the debugger has stopped here, and we can inspect the build object, for instance. If we would have defined a couple of more information, then we would see it here. But yeah, that's it for how Nuke works in essence. And let's stop. Now what I forgot, and usually I want to show this first. If we execute Nuke again now, after we have set up everything, then the build just executes. And we also see at the end, we have some kind of summary that will tell us how the status about certain targets, how much it took for them to execute, and everything else, basically. And now we could just go here and say something like, and we usually use the logger in Nuke, and say something like hello world. And what I like to do in my scripts, I shouldn't call them scripts, but build projects, is usually I do import static members just to make it look a bit nicer. And now if we execute that, of course, we can see our hello world. So that's it for the hello world example. I will now switch to the NUKE playground repository, and that's up on GitHub, so you can go there, clone it, and play around with it. And so now we will just go through a couple of examples that I've prepared. And I need to give a little bit of explanation here. This NUKE playground is a solution that has a source solution folder with one project and a couple of test projects. And also usually you would have only one, but we have in this case several build projects which will all do which will all show different kind of things. And one thing I forgot, actually, let me switch back to the hello world example. One more important thing, and that is especially for resharper and writer users, is what you can do also. You see those little icons here next to the targets. We can actually go here, invoke Alt-Enter, the usual resharper and writer shortcut, and from here we can decide to either execute the compile target or to debug it, or to run debug without dependencies, which is very important for while you're doing the authoring of your build, while you write your build implementation. It's very nice to have that opportunity to just troubleshoot it, don't remove any dependencies and all kinds of stuff. Yeah, and just attach the debugger and be happy. I need to tell you also that, of course, I also care for the Visual Studio and VS Code users. In the documentation, you can also see how it looks for Visual Studio and VS Code. So in Visual Studio, we have some kind of tool window where you can pick targets from, and you have little buttons to attach the debugger and all that stuff. And in VS Code, it looks like that. Above every target, you have code lens items from which you can either run the target or debug it. But there's also a command palette support here, and we can run a target, debug a target. Basically the same thing. Okay, now I will go back to the playground project. And we will start with the target model. So we have seen that already with a small example. But here's a more complex one. We can see this tells us, please invoke NUKE -- plan, and I will just do it. Let me navigate to that particular build. So we need to go to target model. And from here, I will invoke NUKE -- plan. By the way, and I haven't mentioned that as well, with that NUKE global tool, we also gain the benefit of shell completion. So for instance, plan, or let's execute help. And I'll show you that with a couple of more examples. If we execute help here, then we can see all the targets that have been defined and all the parameters that we can pass. And so for instance, for API key, we could simply do NUKE -- AP, and I would just tap now, and it completes to API key. The same goes for other parameters, like for instance, verbosity. And verbosity has a defined set of parameters that I can pass. So I can type V for verbose and complete as well. So that works nicely. But for now, I will just invoke plan. And let's give it a second. And what NUKE does is to create a graph that shows us how everything is tied together. In this case, compile and restore are highlighted already because compile is the default target. Now, if I navigate around and if I hover over the target, that basically means what happens if I invoke that target. So if I invoke restore, only restore will be executed. Compile, restore will be invoked as well. If I go to, let's say, unit tests, then this chain of targets will be executed. We can also see that test, for instance, has a dependency on integration tests and unit tests. So if I invoke that, then both of them will be executed. Now you might wonder, what is that dashed line right here? And those dashed lines indicate, those are, I like to call them ordering dependencies. So those that we have been looking at before are execution dependencies. So I need another target to be executed before me. Ordering dependencies will tell that only if the target is also invoked, it will be scheduled before the restore target. And that leads to the fact, for instance, that if I invoke, let's say publish has a hard dependency on clean, then we can see all of them will be executed, and clean will definitely be executed before restore. Now everything is highlighted. Why is announce highlighted? Because this has a solid yellow line and basically indicates that publish triggers announce. So it's some kind of a forward dependency. I like the idea to have it that way. We could also say announce has a dependency onto publish, but then we would need to invoke announce, which sounds, well, not exactly right. But if we invoke publish due to the trigger feature, we can also trigger announce. It will be just executed after the publish step. So if we go back, we can see how this is all defined. So for instance, let's go to the unit test. We can see this is dependent on compile. We can also see that it is dependent for tests. So we can also define those execution dependencies on the other target. The alternative for dependent for tests would be to go to tests and say dependent on. That's basically the same thing. So that would result in the same definition, basically. It's a matter of taste in many cases. But we can also say that when this is skipped, we should, for instance, skip all the dependencies. So when unit tests are skipped, we could say everything that unit test depends on should be skipped as well. Again, this is a matter of taste and how you like it. For update changelog, for instance, we could say that update changelog, it is a dependency for the publish target, and we could actually say that that we need this update changelog to only execute if we are currently on a release branch or a hotfix branch. So we also can define some kind of conditions for our targets. There's also the only when dynamic. The difference is only when static will be executed at the very beginning of our build execution, and only when dynamic will be executed right before a target execution. So one target could, for instance, prepare something, and another target could decide based on the results of that previous target if it should execute or not. What's very interesting is also the publish target, because right here we can define something like that the publish target requires that we pass the API key, or that it requires the Git to have a clean working copy. So if I actually never tried it, but if we invoke publish, for instance, let's try this. Then, okay, now I'm in the, how's it called? Interactive mode, so it will ask for the API key. But if I was to execute it on Azure Pipelines, let's say, and I can, how do you say, emulate it like that. On Azure Pipelines, I can't be just asked if I can provide the API key. Now we can see none of the targets have been run. None of them, even if just publish requires the API key. So this is some kind of fast fail behavior. We can declare we require this token or this API key. And if it's not there, and I just can't push my packages, then please tell me upfront, and not only when the complete build build chain was executed, so up until there, and it would be a waste of time if those steps take, let's say, half an hour, and then we realize we haven't passed the API key. All right, that's it for the target model. Actually, I want to show you something else as well. It's a very nice thing in ReSharper. In Rider. And this is currently work in progress. We can also have some kind of live diagram, which will show us, just while we are writing our build implementation, how everything works together. So you can see in this case, this before restore is added and removed, and we can see how everything is re-rendered. So in this case, publish is only dependent on clean, but if we add it back, then we can see again that clean is at the very top. Okay, let's go back to the playground. Next thing I want to show you are parameters. And of course, one of the very important things for our build automation or build implementation is to pass in parameters, like API key, for instance. Parameters. And here we have a different build, which is provided already. And in Nuke, what you do is only to write a couple of fields and attribute them with the parameter attribute. That's all that you have to do. So it's basically a very declarative approach of doing parameters. And that results in the fact that here, if I invoke help again, then we can also see those custom parameters here, API key, array param, bool param, etc. Now we can try I have just a simple print target here, which basically just outputs what we have been passing. And we could print should be the default target. Yes, it is. And now we will just invoke it. And we can see most of them are null. Enum parameter is relative or absolute because we haven't passed anything. It will fall back to the default. It's an enumeration, and that's basically the 0 value. Now we can go here and, for instance, pass the string param, hello world again. We can pass the bool param. And for bool param, it's interesting because we can write true. We can also write false, but we can also use it as a symbol flag. So that will work as well. Now we have enum param, and here again we have completion for the possible values. So we can use relative, for instance, and array param. I just have to check what it's a string param. So we could do something like, let me see. And we can also define a separator. We don't have to. By default, it's space. But we can also write something like A plus B plus C. And now if we execute that, we see hello world, true, relative. And also here we have this collection of strings. So this part I have shown you already. So that's it for the parameters. Now path construction. And I'm sure everyone has run into this issue already where you work with a tool and you need to pass a path to a certain file and you pass it as relative, and maybe the tool is not supporting relative paths, could be. Or another case is you already changed the working directory and now the same invocation doesn't work anymore. So the idea in Nuke is to provide absolute paths at all the time. Now I will show you we have this property root directory, which is provided from the base type. This root directory is of type absolute path. And it's basically the same directory as the .nuke file, which I've shown earlier. Now from this root directory, we can do path concatenation with the division operator. So here I can go upwards again into the source folder, for instance. And now this is a very interesting thing with the division operator, because NUKE can internally decide if it should be a slash or backslash based on the operating system it's executing on. So you don't need to waste time thinking about that or guarding against that. And now we have, for instance, we have those definitions, those two targets. They will also automatically, they have an implicit conversion to string, so you can pass them as string as well. And here as the last step from this root directory upwards 2 steps, which is basically at the same point where this NUKE playground solution is located. We could, for instance, make a globbing mechanism and gather all the test folders. And now if I execute that, not yet in the right directory, it's called build path construction. Executing that. And we can see we have this path outputted. So they will also be normalized. And we have this collection of test directories. Now we could, I'm not sure what's the next thing I'm going to show you. It's the right one. Yeah, solution model. So we could, for instance, also gather all the test projects, the CS project files, right? So that exists as well, of course. So use glob files. So you can do that as well. We could glob them. A better approach is the solution model. Solution model. Let's switch to the next project. And with this solution model, what that means is that we automatically have all the we have an API to work with our solution. So basically this thing, the NUKE playground, we can work with that. And that's what the marker file is for. The marker file, you have seen it, it holds a reference to the solution. And I can load the solution in different ways. Like for instance, with this attribute again. By the way, this also ensures we can make those properties, those parameters read-only. But I can also define it with the constructor argument. I could, if I want to, I could also, solution model. I could also pass it, oh, that doesn't work. Let's see. I could also pass it as a parameter. That also works. I'm not sure why it doesn't show here. Actually, it should show here. But anyways, I could pass it as a parameter as well. And this object of solution, if I pass it just again as a simple string, it will hold the normal path. So if I invoke NUKE via attributes, then we will see it will just output the path for both of them. But we can also, and that's what I mentioned before, parse that solution. That's not needed because we have it already. But here it's just repeated. I can actually, I'm not sure why I did that, but that can be simplified. So this is the same object as here. Now if I invoke parsing, I'm sorry, my scrolling doesn't work. So nice. If I invoke parsing, then we can see from the solution we get all the projects ending with tests, and we can also gather all the solution folders. And if I scroll up again, then we can see first we have all the test projects, and then we have all the solution folders, which are basically build, source, and tests. We can not only parse them and iterate over the information that we have, we can also modify them. So for instance, here, modifications, we just get our solution, which is the same, and add a project which is non-existent. And I will just execute that. And now we see non-existing target has been added with just a few lines of code. Very easy. It wasn't really great implementing that, I can tell you. Parsing solution files will never be my hobby, but having it is definitely a great thing. So let's remove that again. Okay, next in my lineup is tool invocation. And of course, tool invocation is something that's really important for build automation, because we use such a lot of tools that are external, like NUKE, the .NET CLI, OpenCover, inspect code, XUnit, NUnit, all those kinds of things. And that was actually one of the first ideas why I started with NUKE, to have a proper way of doing those invocations. And I will show you how. So let's switch back to switch forward to the invocation project. And first I will show you a very easy thing. So the parameters don't really matter. But in its most simple form, it would be great to have some kind of string interpolation, let's say. And I have the .NET method that I can call, which is basically, if I type that out for you, what actually gets invoked is something like that. .NET restore, NUKE playground, and the next line, or should be here, would be .NET build, again, the solution, then configuration. Our default configuration is debug, so it would be debug, but I can also change it. I will do it in a second, and no restore. That's basically the same. Now I need to switch to that again, to invocation, and from here invoke the simple target. It was .NET. I should invoke NUKE and not .NET, then everything should work. So simple. And now for this configuration parameter, again, the same thing what I mentioned earlier. We can call --c for configuration. And then, because this is also, it's not exactly enumeration, but an enumeration-like class. And from here, we know that release exists, and we can execute it with release. Now we see the same as I've mentioned before. Those invocations, and I hope you can see it as it's also colored a bit differently, but there are our invocations. And the benefit of this absolute path is also that I could just copy that and invoke it from anywhere I like. So also the solution file was passed as absolute path. The configuration was passed and the no restore. All right, now let's assume, first another thing. The benefit of having those methods is also you don't need to care about where the executable is located. We can also do it for path executables, or executables that are reachable through the path environment variable. And then we just define a field again, mark it as tool and as a path executable. I could also grab basically an executable from a NuGet package like that. I define the package ID. I can define if I want to have different executables for 32 and 64 bits. And sometimes we also need to define a framework, because especially XUnit is providing executables for different frameworks as well. And those I could use in the very same way. So Git, for instance, I just use it as a method. And here you can see we can pass arguments, but also the working directory, environment variables, a custom logger, if we want to log the output or log the invocation, all that kind of stuff. So that works similar as the provided .NET method. Now, one issue with that, if we go back here, is let's say we want this no restore parameter not to pass all the time, but depending on some other circumstances. Or let's say we want to restore and we want to ignore the failed sources. So ignore failed sources is a parameter. And now comes the Fluent API. With the Fluent API, I can call .NET restore. I can set the project solution, project file. And now I can set to pass the ignore failed sources parameter based on the parameter that I have. So that is basically .NET restore, then our solution, and then ignore failed sources. But only if we define or if we pass that flag. So this is a Boolean, and I could also say something like, if I don't want that, I could also say enable ignore failed sources. This Fluent API gives the gives the opportunity to do that. Another example for this Fluent API, .NET build. We pass the solution, we pass the configuration. Since we restored already, we do the enable nor restore, and we can also pass the verbosity. Verbosity has a defined set of values that it can accept, and with code completion, we can immediately see that. One thing that's interesting about that Fluent API is that we can invoke the quick documentation here and show and see the same documentation as on the official websites. So here's a link to the official website, and we can also see this is a wrapper, a CLI wrapper with Fluent API. And here we can see all the arguments that are able to be manipulated with their respective properties. So for instance, it's not a good example, but this Fluent API supports many types like dictionaries, Boolean strings, all that kind of stuff. So .NET PACK, I will just skip that. Now, another thing, what's really interesting with that Fluent API, we could have a parameter which says to enable coverage based on our needs. So let's say, sometimes you just want to enable the coverage during testing. And we can do that with the extension method when. So the first part is a Boolean, and the second part will be only executed if enable coverage is enabled, if it's true. So we can do very easy composition. And again, here you can see Corporatura. No one has an idea what output formats coverlet supports, but with code completion, we actually do. Another one, let's say we have a couple of projects and we want to call .NET Publish for them, but those projects have different target frameworks. We might need to publish them for different runtimes and all that kind of stuff. First, what we can do is to collect all the published configurations. And this is basically just doing some kind of permutation. We end up with a collection of pairs between project and framework. And now the first part of this .NET Publish is the common one. Configuration will be the same for each and every one of them. The second part is a combine with call, and we pass our published configurations and then just set the project multiple times. So this part here will be executed however or how many published configurations we might have here. I think it's only 2, but even if you have, let's say, 13 or something, this call will produce 13 invocations based on the published configurations that we have gathered here. A nice example is also, let's imagine you have a couple of packages that you want to push. And with packages, it's always interesting. Usually, they could be pushed in parallel. So I think a good number is to push 5 packages in parallel. But also sometimes only one package failed, let's say. And then if you re-invoke the push command for that, you still want to push all of them. So maybe the first only failed. You don't want to adapt your build configuration just to push all the packages. And so with NUKE, what you can do, and again, we have this pattern of calling the same parameters and then combine it with all the packages that we have gathered. And then we can just define a degree of parallelism, 5 in this case. And we can also define that it should complete on failure, no matter what. So all the packages will be tried to be pushed all the time. I think for tool invocation, I will do a bit of explanation here. So currently, this Fluent API is provided for a lot of CLIs out there. So if I go here, and this is actually a bit outdated, but you can see we have it for let's see, coverlet.cover, dubfinder. We have it for Docker. We have it for Kubernetes, Helm, etc., for many external tools. And of course, this Fluent API isn't written manually or something. What we do in NUKE is to gather some kind of meta information and generate it. And as of now, there are roughly like, I think it's 250,000 lines of code generated from this metadata. We can see it here, for instance, if I go to Docker generated to that file, and let me enable the line numbers. And we scroll down here. Just Docker has roughly like 80,000 lines of code. Okay, let's go back. And this is something you can also do with your own tool. So let's say you have your own tool, which is not publicly available. Everything that you have to do is to provide some kind of JSON with metadata, and that contains stuff like this, for instance. So there's an output parameter that we can pass. It's formatted like that. It has a type of string. Here's the help text. And then you can generate that automatically inside your own build project. It gets generated automatically. Okay, let's go back to the lineup. NUKE also has dedicated strategies for build sharing. The first is external files, which works a bit like Git submodules, but a bit more lightweight. So external files, if I go to that CS project file, so here it's just a simple CS project file, then what I do is to define an item group, external files, and I can pass, in this case, I passed a GitHub reference. It's actually a folder, so it's not a file. I can say that it should be downloaded into the download subdirectory. And I can also make a couple of definitions which then get replaced in those downloaded files. Now I will show you right now. I still don't know how I get rid of that, this HTTPS thing here. But anyways, now if I invoke the build here for the external files, then in the output, we can see that all those files are getting downloaded. Has finished. If I go back here, in this case, I need to reload. We have a download folder, and we have all those files downloaded, which are in the same directory. And also, we have replaced some values. So I passed .NET 5, for instance, or the NUKE version. In the original file, it looks something like that. But those things got replaced since we have this definition of NUKE version and target framework, .NET 5, which doesn't exist yet. All right. Another, and just by the way, this is the build sharing approach. So what you can do is to have one build implementation somewhere, and you don't need to care about it, to copy and paste it or something, but you just add the reference and it gets downloaded automatically. Another approach for build sharing is the global tool. And with the global tool, it's something like, let's say we have, this is our build implementation, and I have a target pack, install and uninstall. And this is kind of funny because we are using this global tool project to also install a global tool. But the interesting parts here is that we want to pack this build project as a tool. And we also want to define the command name. So if it's a bit of dog fooding here, because this build project itself will install a global tool at the same time. So if I invoke NUKE now, it will execute this build and it will trigger the install target. So first it will pack the global tool. It takes a moment. Then it will also uninstall the old one, and it will install itself in the current version. And now, since I defined this build command here, I actually have a command build, and this works the same as the build project. So I can call build -- help, and it will be the very same. Now you have seen it's much quicker because it is installed as a global tool. We don't have this bootstrapping scripts involved. Sorry, I have a bad throat today. Okay, next topic, and that will be my last, I think. Yes, CI configuration. So we have seen, I will go back to my presentation here for a moment. We have seen how build servers are of great value, especially with the build prioritization and queue optimization. And wouldn't it be great if we can make use of them, even if we use a build system? So the conventional approach for build systems is that they have those bootstrapping scripts, which NUKE also has. But on the build server, the conventional approach is just to invoke one of those bootstrapping scripts, and that's it. And from then on, the complete build execution runs on a single agent. What you can do with NUKE is, again, we have this build definition here. We have a compile target pack, but we also have a test target. But as you remember, here we have 3 different test projects, and it would be great to execute them in parallel, right? So I'm not sure what I tell you first. Probably the single node invocation. Let's say GitHub Actions and AppWare, they can't run in parallel, at least as far as I know. But it would still be great to have them conveniently executed on GitHub Actions and AppWare. So how it works in NUKE is, again, we have this build class, and now there's a partial file for that, for AppWare, for instance, and all we do is to put this AppWare attribute on it. We define on which images it should be executed, and we define which targets should be invoked, like tests, for instance. This attribute results in the fact that NUKE generates the AppWare YAML for you. This is generated, and we can see the images, and the bootstrapping script invocation. Now, another example with GitHub Actions here. For GitHub Actions, we need to define a name as well, but still we also define the images. We also define the trigger. We can also define more here, also for pull requests, let's say, in a code completion way. Very important. And again, the invoke targets. For the invoke targets, it's very interesting also that we can make use of the name of operator and then also compile. It's not here. Publish. Oh, that's interesting. Build, publish. I think it's not there. Let's check again. But there is the compile. Okay, I have no idea why that doesn't work. But even if, I think that's not my issue, but rather in Rider itself. Anyways, we can make use of the name of operator, and refactorings like renaming would still work. So then let's look at the continuous YAML file. Where is it? Oh, that's hard to find. I will just do it manually. It's here. Again, this is generated. We don't need to care about it, and we can easily run our build on different images by doing so. I will quickly show you how it looks, because here for NUKE I'm doing basically the same, and we can see it runs for multiple images, and we can also open here the invocation. GitHub Actions also supports collapsing certain targets, so we can easily see what happened in the PSAKE target or what happened in the compile target and all those things. Now, those two were single agent CI systems, at least to my knowledge. Let's look at Azure Pipelines and TeamCity, because clearly in those cases, things can run in parallel. Let's get back to the playground again. And we will first look at Azure Pipelines. So in this case, again, the images, invoke targets, and we have only defined, this is only for demo purpose. We could execute compile also on a different agent, but then we would need to do a bit more footwork, because we would need to pack the compilation stuff and provide it to the next target. So defining compile as non-entry target will make sure that test and compile are executed on the same agent. But that's only for this demo purpose. They could also run on different agents. But now for tests. Again, I said we have 3 different test projects, and it would be nice to execute them in parallel. For that to work, we go to our test target right here. And the first thing to make parallelization possible is to define a partition. It's called test partition. And since I have 3 different test projects, I would just say it's a partition of 3. The second thing is I will assign this test partition to the test project. Second step. Just so that NUKE knows that the test target is divided into 3 different pieces. The implementation is very easy. We have seen that approach before. We have a test projects property, which will give us the test projects. And then we just set it, etc. But here's something interesting. The test project property is implemented using the test partition. And it tries to get the current partition from all of the test projects. So if I wouldn't use partitions, the conventional approach would be something like that. And we would get all the test projects. But using the test partition, it will yield the first test project on the first partition, the second on the second, the third on the third. And just having those 3 definitions, the partition object, the assigning, the assignment, and using the test partition to get the relevant piece for the current partition, will give us the opportunity to run things in parallel. So I have here the playground project set up in TeamCity, and we can see we have 3 different test run configurations, and they will all execute a different test project. For NUKE, I'm actually doing the same. Right? We can see, for instance, in this case, I have only 2 partitions. The first partition will execute the I will show you quickly. The first partition will execute NUKE common tests, and the second will execute NUKE global tool tests. And we can also see that the first one has 242. The second has only 1 test. But depending on how your build or how your test projects are structured, this is a great benefit. And I will give you the example of ASP.NET Core, ASP.NET Boilerplate, which is a big project. And for them, I think they had an execution time of 12 minutes before using NUKE. And with that approach, they are now down to 7 minutes. A couple of other interesting things is that we have looked at the parameter declaration. And for NUKE, I will just show you. Let's go to build publish. And by the way, navigation also works nicely. Publish, as seen earlier, requires the API key, requires Slack webhook, Gitter auth token, etc. If I go here in NUKE on Team City, and here's the publish target, we also see it has deploy instead of run because it's a manually invoked target. If I execute that or try, then since those parameters are required, we also see this in the Team City interface, that this is actually required, and we need to provide those values. For Azure pipelines, it's roughly the same. So here is again NUKE build running on Azure pipelines. And here we can see it's running on Ubuntu latest, Windows latest, macOS latest. And if we open that, we can see compile test, partition 1 and 2, etc. Okay, I think that's it for the CI configuration. I still have to show you. For NUKE, the generated Azure pipelines YAML, 130 lines of code that you don't need to invest into YAML. For Team City, it's a bit bigger. Sorry, 300 lines of code. Yeah. One more thing I want to show you, which is not related to CI configuration, is a really cool thing. If you have your build and you're working somewhere else, like NuGet package resolver, with writer and resharper, you can invoke to execute a NUKE target. Then you have all the targets implemented at your fingertips, basically. And we can invoke the hotfix target, for instance. The same as I've shown earlier, we can debug it or run debug without dependencies. And also NUKE integrates with the run anything feature. So here we also have the same support, like ignore failed sources, and we could execute it from here very easy by hitting double control. So yeah, I think that's it. I still owe you the Azure pipelines. I know the Team City attribute here, which looks like that. Here we can also define a nightly trigger target. I think I should close, right? Someone enabled their microphone. Okay, yeah, so that's it. Just to show you a couple of repositories that are already using NUKE, some of the biggest ones that I know. And with that being said, thanks for watching. Would be happy to see you like in our Slack channel, for instance, or on Twitter following or something. But from now on, I'm open for your questions. So thanks for watching.